Welcome back. Today is DevOps Day at Tech Days Online. By the miracles of modern technology and because he's an absolute trooper, I'm sitting looking at my screen now and the marvelous Damien Flynn is here with us on Skype. It's 4 o'clock in the morning in Minneapolis where he is, but still he's here, he's online, and he's going to talk to us about Azure Stack and containers. So Damien, how are you doing this morning?
I think the matchstick's starting strong enough to keep those eyelids working. Good morning. How you doing, Rick? It's a pleasure to join you.
I can be enthusiastic enough for both of us. So just to set the scene a little bit, I was talking a few moments ago, Damien, about the culture and the concepts of DevOps. And I was talking about how things like infrastructure as code is key for declaring our environments and being able to push those out consistently between development, test, and production. And I was talking about also consistency between on-premise and public cloud and hosted cloud. And I think really the stuff that you're going to talk to us about now really starts to show how we can enable that with the power of Azure Stack, which is obviously Azure in a box that I can run, and containers which really span both all three of those environments. Is that right?
Yeah, I think that's very fair, to be honest. I think what we're looking at here is really addressing that first bridge that we have in that DevOps scenario of trying to figure out how can we start implementing and delivering on a solution that allows us to provide that same agility from IT to get that infrastructure in place that keeps up with the cadence that you're working on from a development side. But more importantly, take that same information and deliver it as actual code. It's no longer shipping boxes and patching cables, but it's actually implementing together with our friends in the development teams and in the network teams and in the network groups to actually come up with one single recipe, which is just a set of code, and deliver that out so that we can effectively deliver what it is, the infrastructure that is needed in today's DevOps world in super high cadence.
Okay, so what are you going to run through today? Are you going to do some demos of Azure Stack and containers? Are you going to talk to us about what we need to do to implement that ourselves?
Yeah, that's exactly what we're going to try and do. Now, we prefix everything that some of this stuff is still very early preview. So some demos probably will run very smoothly and some demos may give me a slight challenge. We'll see how that goes. But what I will do is I will go through essentially the two major players that are now coming up in the Windows Server 2016 solution stack as we get closer to general availability. And those are, of course, containers and Docker, as we've seen from the Linux world. And then the second one, which is, of course, the Azure Stack, essentially Azure, but in your data center. And we will spend a little bit of time just understanding what both of those technologies are, how they work and why we care about them, and ultimately how they become the foundation for us to ultimately give us infrastructure as code.
Okay, well that sounds like a great thing to talk about. Well, we got 45 glorious minutes of that, Adrian, so take it away, and I'm going to enjoy sitting back and relaxing for 3/4 of an hour while you take us through all the cool stuff.
Perfect stuff. And at any point during the presentation, if there's some questions or if you feel like we need to jump into specific areas, please do feel free to nudge in there. I'll try and stop talking for a moment or two and just see if the feedback on the channels is coming in or if there's stuff that we should actually clarify a little bit further. So with that, good morning all and thank you. I feel a little bit special, apart from the fact of sitting here at 4 o'clock in the morning in Minnesota, actually at another conference. I'm at the Microsoft Management Conference, or the Minnesota Management Conference as it's known here, MMS, focusing on this same type of technologies. We're talking here about the cloud and how things work, and it's quite interesting to be sitting on a DevOps call, which is mostly about development. But my background is essentially an IT pro, and I think that's a tribute to where this technology is coming from and how this enablement for giving DevOps type solutions is now becoming far closer to reality. And today I hope that we leave with at least some working knowledge of what the technologies are and how we can work with our IT partners and start lining up what it is that we need to essentially deliver on in order to enable us to bring out different technologies through infrastructure. So my background as an IT pro has been really on the actual fabric. I've been working for a number of years as an MVP, focusing in on the private cloud, Hyper-V, System Center, and the software-defined world of networking and storage. And of course, then the piece that has bridged me towards automation has been, to DevOps has been two main areas. That would be, of course, automation and authentication or identification. So the federations and the Azure Active Directories of the world, where I've had to build lots of relationships with my partners in development, and also, as a reverse of that, be their representative as I worked with my own partners in the networking teams and stuff, so that we essentially knock down the balls and start working as one single unity. And it's from that perspective that essentially has helped me to start really understanding and appreciating the challenges that everybody has in this DevOps challenged environment today. So what are we going to cover, and how are we going to do that? Well, we're going to make this kind of easy. We're going to start with containers. These are brand new to Windows, but if you have been working in the Linux world, then this is old hat to you. So we'll talk a little bit about what that is, how the containers are, and what they mean in an infrastructure as code type solution. The next one is the Azure and Azure Stack. Now, sometimes it's a misnomer that Azure and Azure Stack are different. Be very clear on this. Azure and Azure Stack is Azure. The only difference in Azure and Azure Stack is one, and that is you as an organization are responsible for maintaining the stack. It is essentially your job to manage that fabric. Where in Azure, obviously, guys in Microsoft are managing that fabric. But from an experience, it starts and it stops at the resource manager. Now, what the resource manager is, we'll also spend a little bit of time today, because this is really the front door for true infrastructure as code. While containers allows us to get so far down the road, Azure and Azure Stack, through their resource manager, they get us right through to the very front door. They offer us a huge amount of stuff, and we'll look at that as we move through. And then finally, of course, we need to take a feel for how does this actually work in my development project. So I'm going to do something quite unusual for an IT pro. I'm going to spin up my Visual Studio. I'm going to write that little bit of infrastructure as code so we can just see what it looks like and get a feel for it. But then I'm going to get really funky, and I'm going to load up Visual Studio online, configure a build controller, and then even go as far as actually the release management, as just start thinking about how all of this works. So infrastructure is sitting right there in the very center of your code repositories for your projects, and is truly part of that solution. So we have a fair amount of bits and pieces to cover. So I suppose the only thing that's left to remind you is that we are online. There is lots of people manning the Q&As and the Twitters this morning, so please get those questions in, and hopefully Rick will be able to become the interrupter and get some of those questions in front of me this morning, so that we can address them here on stream.
I think, at least I hope, Damien, that you're going to manage to sign into the chat channel and maybe hang around for a little bit of today. Obviously, before you go off to the management conference at sort of 8 o'clock, you might manage to spend a bit of time online with us answering questions yourself. Is that right? Yeah,
absolutely. There's nothing a lot happening here from 5 o'clock until 8 o'clock or 9 o'clock in the morning. So yeah, absolutely. And going back to sleep is not happening, because obviously my time zone really is the time zone you guys are on. So I'm up, so I will be sitting in there and keeping a good eye on you guys. Okay, so to keep me honest, and just check the clocks, and it's 20 past the hour, so I think we are in good shape. And I suppose I have a message in front of me, which is, I think, very obvious. Before we start writing a single piece of infrastructure code, there is no point in doing this unless we understand what we're doing and why we're doing, and for what type of a platform that we're going to work on. It also helps a lot of the time to understand how that plumbing works. So that's essentially the theme for the first and second parts of this presentation. We're going to learn a little bit more about these technologies. So the first of those is containers, and Windows containers as a whole. There are a number of changes happening in the operating systems. But really what we're doing is we're embracing an ability to have multiple operating systems running, very similar to what you've been used to with Hyper-V and virtualization solutions over the years, with a number of major changes to how that process happens. And the key one really is that if you've been running Hyper-V and you needed to get your virtual machines up, absolutely they're fast, they're secure, and all of those brilliant things. However, you still need to talk normally to your IT colleague in order to get a virtual machine up. Now, in some cases, they've simplified this and they've bolted on a self-service solution, maybe using something like the Windows Azure Pack. And you'll be able to go in there and write an a la carte list and essentially subscribe to your own virtual machines. Even more advanced, you may actually have gone ahead and used the APIs or the Azure SDK to actually communicate with something like the Azure Stack and write a PowerShell script essentially to say, go ahead and create me a set of virtual machines. So effectively starting to peel that onion as an infrastructure as code. The big problem here is none of this is really, really fast, and writing these scripts can be quite troublesome, especially if you're coming from a development side and have not a lot of background on what's happening on the actual Hyper-V pieces, or if your IT guys have been doing some special things, there may be a set of commands or configurations that you need to apply each time, and if you fail to employ them, something may not work. Now, depending on how well tuned your environment, that's all good and well. However, the biggest challenge we have in this is there is some sort of a drift going to probably happen between the versions of the machine that we're using for development versus QA versus staging and of course against live. So we have these different experiences, so we take our application and deploy it. And the concepts that we're trying to address here is to fix that. We want consistency essentially from the day we start in our development cycle to the day we put this thing into production. And to do all of those things, we are essentially going to wrap all of these technologies with a very defined piece of code. And the code is really just a set of instructions of what we need. It's clearly written in pretty much human readable English, and allows us to define the baselines that we require. And from those baselines, we are very clearly going to essentially repeat every time we need the new environment. Now, if this was slow, we're not going to actually leverage it because we're not going to wait. However, the concept of containers is that it's going to get you the absolute minimum that's needed. So from our perspective, we deliver you an operating system, and on top of that operating system, we enable the services for containers. That will be Docker's platform. Now, from within the container, what we're essentially talking about is we're giving you a virtual machine, probably the best way to describe it, which has an operating system and nothing on that operating system. Keep it as minimum as we possibly can. So no GUIs, none of this stuff, and just the binaries for your application. Now, that tiny operating system we're keeping in the back end obviously means that the deployment time for this is going to be as fast as we possibly can because we've kept it small. And then add on top of that the size of your binaries, and we have a pretty good idea that this should be fast enough to copy out. But what makes containers really special is that once you've deployed your first container, if your second container happens to be running against the same host operating system, so the same binaries for your OS, then the container technology is smart enough to say, well, you know what, I don't actually need to copy the OS over because that's already on the machine, so I really only need to deploy the binaries of your application. Now that, while it sounds a little bit odd, is actually fully isolated. So even though the operating system libraries are shared now between more than one container, they are still isolated. The applications are still isolated from each other that are running in containers. So it's through the magic of layering an onion type solution here that we've been able to essentially present the same operating systems up into different containers, and because of that, the deployment times and the processes for making these things happen is really, really small. Now, it's pretty well tried and tested. This technology on the Docker platform have been in Linux and Linux kernel for quite a number of years. And it's only in recent years that Docker has really come up to the forefront, and that is essentially a management tool around the features that have been sitting in the Linux kernel for many, many years. What's happening now in Windows world is that same set of technologies or same concepts have been brought over into Windows, so that we have that layering functionality, and we're also getting, with the cooperation of the Docker team, or Docker Incorporated, the same experience of actually working with these containers in Windows. So it really doesn't matter if I'm on a Windows host or a Linux host as we deliver the service. Now, as an IT pro or as a developer, really all that we need to focus on once we've got that host server in place is that the build experience that you guys are working on is essentially exactly the same as you've been using. You're going to continue using your same Visual Studio tools, and really all we're going to do is we're going to target ultimately that we deliver our package into this container. The containers are all built on Windows Server 2016, so grab yourself a copy of TP5 and start playing with it. It's free, download it and test it out, and of course if you're not happy with what you see, now's a really good time to get feedback into Microsoft, and you can do that through many different channels, including user voice. So a quick Bing will allow you to actually find the user voice for this solution. The management of this then is consistent. It has docker.exe, so essentially you can run all the same Docker commands you used to, Docker build, Docker pull, or you have the choice of running PowerShell if you've become tightly affirmed with PowerShell as a methodology and as a scripting process. Then there is a rich PowerShell experience for this. One of the other features that we get in containers is resource management. So we do get the ability to throttle and control CPU, memory, storage, and network. So if we do get containers that we figure need to have the ability to grab a lot more of your host, or you figure that there's a bit of bad code in there and he's becoming a noisy neighbor, we can go in and modify that container and put a set of bounds on it to ensure that he behaves himself. And then, of course, the last piece of the puzzle has got to be the network. So once the container is up and running, we need to have some sort of a methodology of communicating with it. And just like in the Linux world, where we get essentially a bridge, that is a connection from the container to the physical host, and then from there the host's own networks connect you out to the big bag at the internet. In Windows containers, we can do exactly the same. There is one major benefit though in the Windows container implementation, in that that bridge connects you directly to the Hyper-V switch. So behind the scenes for this isolation piece to work, the VMMS, which is part of the Hyper-V services, is what is helping to ensure the OS isolation pieces all work. And that allows the container to actually go and communicate directly to the Hyper-V switch. That, as a result, then allows us to actually leverage things like software-defined networking. So we could actually build multiple containers and actually wire these up to use SDN technologies, or of course continue using VLANing and bridging or NATing or whatever it is that we want to do in the container world.
So Damien, does that mean that if as an organization we've invested a lot in System Center, Virtual Machine Manager, we've really bought into the whole virtualization as it is at the moment with software-defined networking and virtual machines, that we're not going to have to retool, we're not going to have to throw that away, we can take advantage of that and layer containers on top?
That's actually a tricky little question, to be honest. It should be a simple yes, but the reality in this one is it's not a yes. It's a maybe. So yes, we will certainly be able to leverage the VMM environment for managing the stuff. However, the software-defined networking parts of this world in 2016 have essentially been completely re-architected. So if you have bought into the software-defined solutions that have come out in 2012 or 2, those don't really transpose into 2016. So we're going to definitely have some challenges as we start figuring out how do we embrace the 2016 software-defined networking. And that really is a topic for another day. But yes, there are some challenges there to address. So the other isolation functionality is actually Hyper-V containers, and this is something special to Windows because of course, as I mentioned on the last slide, the container isolation is somewhat controlled through the VMMS, which essentially is part of the services in the background that are the Hyper-V technology stack. Microsoft made a simple realization that they could actually offer containers something that isn't available in the Linux world, and that really is a very consistent experience. So essentially, even though Microsoft have this concept of regular Windows containers, we also now have this concept of a Hyper-V container. The images we build are exactly the same. They're still 100% compatible, but the major difference here is that the operating system that's sitting in the bottom is fully isolated using Hyper-V isolation technologies. So the experience of deployments, the size of the deployments, all of these things remain essentially exactly the same, with one super key difference, that the Windows kernel that has been shared between the containers in our first scenario are now fully isolated in this Hyper-V scenario. Now this isn't for everyone, and most people are probably just going to go with the regular Windows containers. But this one does have, I suppose, the benefits of I'm writing code that is to be trusted. I'm writing code that I want to completely isolate from everybody else, and in those specific scenarios we can actually bring up the Hyper-V containers and get them communicating with the Windows containers in the same environment. So there isn't a I must do one or the other scenario. This is really a decision on the container level to state that this is a special container. I need to treat this one a little bit differently for whatever reasons are coming into place. And sometimes this might be just down to a business decision saying, you know what, I want all my containers to be fully isolated and run the same way because I'm just not sure I want to have that shared kernel scenarios right now. Or it could be the exact opposite and say, look, we're running containers, we're going to run fully shared. So this is definitely a decision point that you guys get to make. And playing with it and working with it is what's really going to make the decisions for you as you move forward. The one thing you can easily rely on though is that it is consistent and compatible. So if I do make a decision to say I'm going to push out a Windows container and then change my mind, I just rerun the actual Docker file, the configuration file, but this time define it that I'm going to define it against a Hyper-V container. So there's no major, oh gosh, I made a mistake, I need to go back and change my mind. And one of the other things that's probably very important to highlight, and also again that call to action, it is Technical Preview 5 at this point in time. This stuff has been in the cooker for a fair amount of time. There's been a whole lot of optimization going on. We have a very special operating system now, which has essentially most of Windows cut out. We're talking about 300 to 400 megabytes in its tiniest form, and that is a Windows Nano Server. A Windows Nano Server is designed specifically for this container solutions. And as a result of that, the hypervisors or the VMMS in the background has also been strongly optimized to essentially make sure that the nano services that are used in containers run as efficiently and as effectively as possible. Now, what hasn't happened is a huge amount of testing for different types of workloads, your applications. And that's why I'm calling for action, that if you are anywhere interested in doing containers, you couldn't be at a better point in time as we get towards the TP5 and into the next set of releases, that we can get tests, see how this stuff works, and if it's not working, get that information back into Microsoft while this product is still being developed and optimized.
So the call to action there is for me to go and download it, install it, and start kicking the tires of this. Yeah, Damien? Absolutely.
Absolutely. So how does all this stuff work? Well, really at the top of the picture, we have essentially orchestration and cluster management. It essentially, It's a management tool like VMM, essentially what we're looking at here. Because as we start putting out containers, it will be a little bit like putting out virtual machines was at the start. We're going to have a whole lot of them to mind and take care of pretty quick, because once people start embracing this technology, it's going to become pretty obvious that it has some serious benefits as we look at our infrastructure as code solutions. It's going to give us the abilities for us to get our developers onboarded very quickly with consistent environments, and of course we can take a container, drop it in a repository and push it into production. So we will want some sort of an orchestration management tools. There are a number of tools already available, including things like Hive and Swarm, Mesos, and so on. But for now, your focus really will start at the next level, and that is either using something like the PowerShell module. The PowerShell module is going to make a communication back as far as the WMI on your host, and that will then essentially communicate with the VM management service. Or if you have already been a Docker user in the Linux world for many years, or just want to standardize on using simple Docker commands so that you can move between those two worlds, then you can of course intermix and run with the Docker client. The Docker client makes a REST API connection back, and that speaks essentially to Docker Engine service. Both of those, however, communicate back to the service layer, and that service layer then is what essentially tells our host and configures both the compute and the networking side, all sitting on top of our container-enabled Windows server. So essentially what we're looking at here is there are two doors into this experience, and the nice piece on this one is both doors are open, so you can manage this through whichever methodologies you feel, and of course regardless of that, you're going to put some sort of a management solution on top as well. So you're not being essentially streamlined into saying that the only tool you can use for managing these containers is X. And a lot of the investments and work that's going on at the moment is to try and make sure that these container management tools are hybrid. So regardless if your containers are running on Windows or on a Linux host, the objective that a lot of these organizations have is to make sure that these management tools and orchestration tools effectively treat both container hosts as first-class citizens. So that's essentially what we're looking at. So how does that rule back as far as DevOps, and how does the experience work in the real world? Well, really what we're doing is we're going back into our projects in Visual Studio, and we're adding a new project, and under that project we're going to add in essentially a file known as a Docker file. It's a very simple text file which defines the operating system that we're going to use as the base, in this case our nano file, and then essentially a set of steps that we want to happen once the base operating system is put in place. And that really will be about, I want you to pull in a copy of my application build, I want you to start the build using this particular command, and then I want you to stand down and come out of the way because my Docker build is done. And that is all that goes into your Visual Studio. It is just that Docker file, a really light text file. That file then essentially gets pushed into a repository essentially, and normally that repository is built. So what we end up happening essentially is through the build process, we build the Docker file. So we follow the recipe essentially and tell it go ahead and actually grab in that operating system and pull all those things together, and we end up with essentially a file that might be a few hundred meg, and that file will be split into, I suppose, layers of that onion, and those layers will be pushed up into that repository. Now, each of those layers of the onions have a GUID essentially associated with them, so that as we go through and we start making new versions of our application, what we'll find in the Docker file is that the Docker file may not actually change at all. And we may also find that a lot of this onion doesn't change either. The operating system piece still remains exactly the same, and the only piece may be the outer skin of the onion, which essentially is my build. So I may have to pull in a new build, drop the old build, and effectively that's the only thing that ends up getting pushed into the repository. Everything else can stay the same because it hasn't got touched, and that's what makes this thing so fast at getting deployments in place, because it's able to be really smart and figure out what's got changed versus what hasn't, and then only the pieces that have changed in this pie actually need to be pulled back in. Now, on the far side of the picture, we've got our operations team. So IT are sitting here, and we're looking at that same repository. We've got maybe that management and orchestration tool sitting in front of us, and we're going to basically take a look at what just happened into the repository and maybe pull that project out and put it up onto our actual production servers. So of course, development work will be happening local to the dev, but as we move into the actual real world of production, we might still have some gating factors for approvals to get stuff moved into the different production environments. So operations may still be involved in that whole process, or this could of course be automated. But their task essentially in this process is taking it out of the repository and getting it up onto the actual hosts that are going to run these containers for whichever of the environments that this may be. And then because we've got a view into what's happening in the environment, so we know that the container is running, the load on it and its performance, and of course that may mean adding multiple containers at different tiers. So if your database tier or your web tier needs to be scaled in or scaled out, then that's the stuff that we're going to start seeing. And in a DevOps scenario, IT are going to give you access to those consoles, or at least share you with the metrics that's coming in and out, so you can take a look at that and start understanding, okay, so it's behaving slightly different when we put it up onto the big beefy production servers. That's great, then we won't need to scale as much, or oh, this is doing things that I didn't expect when I moved it into production. So we can start figuring those things out. And those sort of experiences are really down to the fact that we've got lots of users hitting these boxes now, not the fact that we've got a difference in that the production system is running a different version of the .NET framework. That stuff is dead. We don't see that anymore because we are now running that exact same container. So the debug and the experience on that lifecycle has become an awful lot easier. And then it's repetitive at that point. You just go back into your code, update your code. As a result, the Docker files get pushed back into the repository, and then that in turn gets pushed back out as the physical hosts, and that lifecycle goes on and on and on. So that's essentially the Docker and container story and how it runs in our DevOps side of the world. The next story is the Azure Stack story. Now, calling it Azure Stack or calling it Azure is almost irrelevant and maybe a misnomer. As I mentioned earlier on, there is no difference. Azure Stack and Azure are exactly the same, with the only difference being essentially that Azure Stack is your responsibility to run. Azure is Microsoft's responsibility to run. But that's in the plumbing and that's in the IT piece of the world. That effectively means get this thing into your environment, get it running, make sure it's stable. And we are on technical preview 1, so getting it running and getting it stable, that's not even something that we're worried about in this version. This is really focused on nothing more than the resource manager. It runs on a single host in its TP1 environment, and it has teething issues. There are loads of challenges with performance and stability and all of those things that goes on, but nobody really worries about that. In TP1, the only thing we care about is that the resource manager does what it does and does it right. We're working in that consistency layer so that when I build that infrastructure as code file and I start delivering that out, that it behaves as I would expect.
I think that consistency is really important to get across, isn't there, David? So we've been running Azure Stack on the preview of Black Marble for a while. Before that, we had Azure Pack. And Azure Pack was not the same as Azure. So you got similar services, but the underlying stuff that ran them was very different, whereas Stack is Azure in a box that I run with pretty much total consistency between the servers. Is that right?
That's exactly it, Rick. There's no question. Azure Stack is the consistent story, and the other topic obviously is Azure Pack. What happens to Azure Pack? Again, that is it's actually a presentation I'm doing here later on today. Azure Pack versus Azure Stack. It is not Azure Pack is dead scenario. That is definitely not the case here. These have two different places in the world, and for us in this scenario, what we're talking about is exactly that. It is consistency, consistency, consistency. Azure Stack and Azure is Azure. And as long as we're very clear on that, then this consistent story becomes really, really important, because that means I can take that workload and I can put the workload either onto public Azure or onto my private Azure. That's really all we're talking about here. And the fact that this is technical preview and it may have some teething issues with stability and stuff like that, the product teams and everybody else is very, very clear on, we don't really expect it to be working very strong at this point. We just want to know that we've got a lot of this plumbing working right, and we'll fine tune how we actually deal with the stuff in the underneath, that IT part of the word, as we move through the technical previews and get this into our data centers and scaling it out from just being a single POC type install. And your mileage varies. I've had lots of different deployments, and sometimes these deployments have been extremely stable and running very well, and then the exact same code, the exact same builds pushed back out on another day. Yeah, it just hasn't been very good, so you just roll it over and do it again. But one thing that has been consistent is that concept of taking a template, my infrastructure as code, pushing it up into Azure. Okay, it works. Now bringing it back down, and okay, it works, except the stack had a failure trying to move a hard disk for me. But okay, I know what's happened. I'll rerun the template and it passes this time. So what is a resource manager? This is what you're going to start learning. If you're going to do the Azure side of the world, the resource manager is your best friend. And understanding what the resource manager does and how he does it is really key to anything you want to learn in Azure. Forget about all the other pieces of the plumbing. It's not important, because ultimately we're building a cloud here, and we're not going to be tweaking with this stuff. Once it's up and running, it's up and running. So we have essentially the concept of resource groups, and the resource manager allows us to essentially group different artifacts of our application into groups, and those groups consist of essentially the backends of providers, and a provider essentially is an instruction target to turn up something like a network interface, a compute node, a website, a SQL database, and as we push more functionalities into our stack, or we look at what's sitting up on Azure, you'll see that list of providers will be short for the on-premise one and extremely long for the stuff sitting up in public Azure. But as we see this mature and get more and more functionalities into our on-premise Azure, you're going to get more and more providers turning up more and more functionalities. Those functionalities are what are being driven through the template. So really when the consistency isn't there, what's happening essentially is we can take a template or an infrastructure as our code file, or a JSON file in this case, that basically depicts that I would like a virtual load balancer connected to my switch, and I would like that then to be connected to the network interface that's connected up to my virtual machine. Now these are all different little pieces of resources, and out of the box all of these core resources exist in both environments. But if I also decided that I needed to have something like an automation account or an automation service, then that does not exist in Azure Stack today, but that does exist in the public Azure. So in our template, that template isn't going to work on premise. It's going to basically put a little bit of a heat cup up saying, hang on, you're looking for a resource that I don't actually have present. But the other piece of this then allows me to tag these resources, and I can tag them any which way I want. Colors of the rainbow, shapes of the moon, names of projects, environment names, whatever it is that I want to utilize to help me identify what we're pushing out, and that can help me in my billing scenario. Now the other thing that's quite interesting, and we'll take a little bit closer look at this, is access control. The resource manager is built from the ground up to address something that we didn't do in Azure Pack, and that was deal with security at that granular level. So the resource manager allows us to actually take our OAuth, which essentially means it's an internet ready claim, and effectively decide who is allowed or not allowed to leverage either the resources or the resource groups. So if I go back and I talk about that automation account that doesn't exist on premise, it might exist on premise, but you may not have any permissions to see it. The net result of deploying that template will be the same thing. It's not there, because now this time, it's not that it's physically not there, it's that physically you've no permission to it. So the access controls will make some of those decisions. And then on the very far end, we have this policy module, whose job is to make sure that you're following my guidelines, because we're obviously handing out the keys of the kingdom for you to do as much as you want and build the infrastructure, but every organization has a set of standards. There's a set of requirements that we need to have in place for how we might want to name our servers. We might want to make decisions about the type of disks that we're pushing out, or the size of the disks, or where we're putting them out if you've got more than one location. So the policies allow us to actually go ahead and put in a set of restrictions that will check that template, that infrastructure code, to ensure that you're meeting all of those policies before we move forward. So it's a very rich platform for communication on, and that is really where we're going to spend our time actually learning and working on this thing. So if we think a bit about the security piece for a moment, essentially, again, the front door for everything that is Azure is the resource manager. And you're going to hear people talk about the resource manager with lots of different names. It's known as ARM or ARM, or the Azure Resource Manager, or as I'm calling it today, just Resource Manager. But it is the one and same thing. It is the heart of Azure. And in this particular case, the resource manager is built on the concept of everybody that's coming into my cloud is going to have a subscription. Now, you could be a team member sharing a subscription with the rest of my team. It could be a department. It could be a tenancy, and I may be a hoster. So I may be a customer coming in. I may have more than one subscription. But that subscription essentially becomes a boundary. And within that boundary, I can actually build more sub-boundaries, like resource groups. And we talked about resource groups as being just a simple grouping of all of the resources that are important to me. Now, how I bind these, again, is completely up to me. I may make a decision that I'm going to have one resource group that's going to host all the storage. I have another resource group that's going to host all the compute. Or, probably in more realistic terms, I'll have a resource group which resembles my application. And for each application, I put out a different resource group. Or I may have a different development environment, and I might decide that I'll have a dev resource group and a staging resource group, or I could have it even tidier. I may have an application for development resource group, an application for staging resource group. It's really up to you to how you actually architect these to suit your models. Well, the thing here that's really important is each one of these resource groups can be tagged and can have that role-based access control. So that granular security can be applied at those resource groups, saying that I want to restrict who has access to the production servers. And that restriction could be quite simply, we're all one company now. So I'd like the dev guys to still be able to get in there, still see all the production servers, but I do not want them being able to turn them on or turn them off, or scale them in or scale them out. They can look, but they can't touch. Where over in the staging environment or the QA environments, we may have made some different decisions, saying, you know what, this is a QA version, we may want to make it easy for people to just restart the environments. This is now all possible. We also have the ability to actually do this tagging and RBAC at the resource level. So even though I've turned around and says, you know what, the dev guys are not allowed to actually touch the production servers, they can look, but they can't touch. We may be aware that there is a scaling requirement, and Rick is being very generous to decide to work over a Christmas period, and the website that we're running may need to be scaled, and as a decision for doing that, we're not going to automate it, we're going to do it manually. Then I can actually tag that resource, that web resource, to say, look, Rick is the god, so therefore he's allowed to scale this thing in and out, and ignore the automation decisions to scale stuff in and out, but just on this one resource. So we can make that level of granular decisions and control this across our whole environment. And this becomes a very, very flexible yet complicated option for us to make sure that we work as one unified team through the confidence of role-based access and audit in the back end, so we know what's happening as well, which is obviously very important for us. So, how does the resource manager work? So the resource manager is actually, it's a logical engine, and what I'm going to depict here is based on what I have figured out from using TP1, and this really is going to be a very clear representation of this stuff will change, because this is where we talk about it is a technical preview 1 and some stuff doesn't work very well. So the flows I'm going to talk about here are probably not going to be the same when we go to TP2, and they'll probably change again when we go to TP3 as Microsoft go through the environment and re-optimize it to make it even better. So what do? Well, we basically take that JSON file. Now that JSON file is our infrastructure as code, let's be clear, but we need to make sure that it's correct. If it's not, then we're just going to throw it away, pop up a message and say, nice try, however, your code's not good, go fix it. The next thing we're going to do is we're going to check, who are you? Have you privileges to do this? Are you allowed to actually make compute accounts? Are you allowed to call for automation? Are you allowed to hook up networks? You are? Not? Okay, go away. Or, okay, we're happy. We've passed the validations and you're good to go. So what I'm going to do now is I'm going to actually go ahead and I'm going to check for storage, because obviously I need to make sure that as I deploy my virtual machine that I have somewhere to actually put the disks or maybe the builds. And the first thing I'm doing in my infrastructure code is checking to make sure that I have a storage location for these things. Now, if the storage location's already been provisioned, then I'll be just wired up. But if it needs to be provisioned, then another flow is going to kick in, and that's going to start that whole process of figuring out, again, what's necessary to build out the actual storage world. Now, we'll repeat that same process from a networking perspective. Before I actually put a network interface and wire it up, we've got to think about how we would have done this in the physical world. I would have bought the server, I'd have racked it, I'd have hooked it up to the switches, and then I would have probably powered it on, started putting in the operating system, and then configuring it. Well, this is no different. I'm now going to call the network controller. The network controller is going to check and see, do I have that network that we are looking to connect the virtual machine to? Oh, it's a new network, so if that's the case, then I better go tell the controller, well, define the new network, tell the switch to support this new virtual network, and then turn on the ports and get the tag in that virtual switch ready, so that now we can go ahead and then be ready to actually hook up the actual cables to our virtual interfaces. So all of this is happening in software. There's nothing really happening in the physical world. There's no Oompa Loompas running around the place actually plugging stuff in anymore.
I quite like
Once
the
we
idea of
have
Azure
those,
Oompa Loompas.
I love them. Willy Wonka rocks. Once we've got these in place, we can now start with the process of actually trying to actually place our virtual machine. And this is when the resource manager starts to get a little bit sophisticated. He has an engine sitting under the hood called the placement manager, and his job really is to understand how many hosts exist in the topology. Hosts being obviously the Hyper-V servers in this case that can run the environment. We then determine what those clusters look like. And the other piece we need to understand is availability stats, because as we deploy stuff into the Azure world, we want to make sure that we're in a scenario that we have at least 2 copies of everything and that they're in different availability sets, because Azure has this whole concept of, I'm going to patch the stuff in the background and I'm going to take down stuff without telling you. So as long as you build them into availability sets, you're good to go, because you will always have 1 copy online. We'll guarantee that. So essentially this is the very first piece of the puzzle here, is checking to make sure that we fit into those availability sets. And once we've figured out those, we can then provision the compute. So we now know which host we're going to put this virtual machine on, and then I call the compute controller, whose job essentially is to go and start provisioning that actual virtual machine for me. Once the virtual machine has been defined, I need to go forward then and provision the actual disks, and that really calls in another subsystem of the environment, which essentially is part of the extension manager, and we're going to pull out from there the images, the platform images. So what we're really talking about here is the operating system. Now, these, of course, don't have to be Windows. You can have Ubuntu, CentOS, and Microsoft are already working very closely with these guys. And if you go to their own website, so head to Ubuntu or over to CentOS, you'll actually see that they actually have pages for Azure Stack ready images. So this is pretty serious stuff. Everybody is getting on board here. We put those essentially into our repository, and then in this particular case, we're going to pull them out of the image library or image repository and actually get those dropped into the storage for this virtual machine. Once that's complete, we now can go ahead with the network controller and talk to the network that it provisioned a little bit earlier on. We didn't obviously drill into the particular steps that was necessary in that case, but the network controller will now go ahead and actually do all the wire-ups that are needed for this virtual machine. And then we gave it the go. Now the virtual machine powers on, and the very first thing it does is it clicks in an Azure agent. Now really all this Azure agent is doing is it's basically following more rules in your infrastructure as code. And the key rules that he's going to appeal to at this point is maybe things like the IP address, virtual machine name, and any OS profiles that necessarily need to get pushed in. So those are happening through attaching an ISO file. So we're doing that OS customization to make sure that we have the operating system the way we want it. And then the final step in this mess is probably one of the single most powerful features that we have in the Resource Manager, and that is the concept of VM extensions. So at this point in time, what's happening is that we call back in the Extension Manager, and the Extension Manager is now going to pull out some metadata and artifacts. Now, what am I talking about here? Essentially, what we've done in our infrastructure as code is we've put in a note in here saying, I want to make sure this machine is monitored. I want to make sure this machine is backed up. I want to make sure this machine is protected for antivirus. And I want to deploy a configuration on this machine which will actually stand up my application. Now, to do those things, we're actually using the metadata and the artifacts, which are essentially more executables that the Resource Manager is now going to push into that running operating system. Those are going to happen in sequence, and ultimately, if, for example, the last piece that I pushed in was the configuration, then I may have an extension which turns up Microsoft's PowerShell desired state configuration functionality, and that may have a metadata file attached to it which says this is the configuration that we need to run on the machine, and that might be stand me up as a domain controller, it might be configure me as an ADFS server, or it might be here's my application, pull that binary in from this particular location and run the following command to install it into the environment. And once that is done, and assuming there's been no problems, we end up with a fully running resource.
Sorry, Damien, I hadn't realised there that I'm using Mr. Fryer's laptop, and Microsoft IT helpfully tried to issue an update while you were talking there. I love technology, it's great.
It certainly is. Certainly is. So that's essentially how the Resource Manager works. That's what the plumbing is that's going on in the background of that, Rick, and allows us essentially to start understanding what's happening. So we have effectively looked at the two major players that are in Windows Server 2016, the container model or the Azure model through the Resource Manager. So which way you go is really down to your organization. Both of them are actually very easy to use, and there is no guideline to turn around and say you should use one or the other. It may be a combination, and it's really down to you to actually start trying them out, figure out what works for you, and adopt an infrastructure as code approach to doing these. So what I'm going to do now, assuming the gods will allow me to make a connection the whole way back to Ireland, is I'm going to actually try and get back into the lab. And from there, we should be landing and seeing, hopefully, my Azure Stack solution. Now, if everything is good and well, my Azure Stack is going to be very good and behave, and it's going to be cooperative as we run through this. But what we're going to try and do is I'm going to spin up a copy of Visual Studio, and in Visual Studio, I'm going to attempt to build a new infrastructure as code project. Now, from a developer's perspective, really what I should be doing in this case is I should be actually working on your existing project or solution and adding just another project in there. Now you'll notice in my Visual Studio I've got this node called Cloud. Now that doesn't exist there by default. This is essentially a byproduct of installing the Azure Software Developer Kit version 2.9. Which I think is the current version, and that really has the concept of allowing us to build Azure resource groups. So I'm going to try and go ahead and I'm going to do a resource project, and I'm going to call it Tech Days 2016 Online.
So Damien, the AV pixies are waving frantically at me that we're going to have to wrap up soon, so we might not get time to do the full Release Manager deploy, but if you can show the creation of the cloud project and maybe do a quick spin through Azure resource templates, and then maybe we better call it quits at that. That's okay?
Yeah, absolutely fine, no problem at all. So I'll click into this one. So, and what I will do, Rick, is that I actually have, because we weren't sure how the gods were going to play out, I actually have done a recording of this whole session already. So maybe we can actually put that up for everybody to review at a later point, which actually does walk through the complete release cycle too. Absolutely,
I'm sure we can do that, and I'm sure Taryn can probably touch on it when he talks about Release Manager after the break. And if people want to know more about resource templates, then they can look at my blog, because as an Azure guy, I live and breathe these things. And I think the really good thing for me in all of this is that all of the skills that I've learned when dealing with public cloud are now suddenly transportable into my own premises and my own environment. And I know one of the things that I want to do is to replace Lab Manager that we use, which is built on top of System Center, with Azure Stack. And the story for us for deployment and management is going to be really, really nice then with a consistent approach of templates.
Yes, and I think this is obviously one of the big wins here, because Lab Manager, as you said, works with System Center, but doesn't. It didn't embrace a lot of the concepts that Virtual Machine Manager were delivering for clouds. Now we have a very clean, unified solution from end to end, from development straight through to the IT, the hosting of these operations. So I agree. I think this is fantastic for a roadmap scenario. Okay, so conscious of time, what I'm going to do here is I've just opened a brand new solution, and under that solution I've got two templates, a deployment template known as Azure deploy.json and a parameters. Now effectively these are empty. They're very simple blank JSON files, and what I'm going to do, and I've chosen in the wizard while Rick was speaking to use an empty template. There are a number of predefined ones in here, but I've chosen to go empty just so that I can show you how hard it is to write infrastructure as code. So in this particular case, I'm going to actually say I want to add a new resource, and again, I love the wizards, and if the wizards love me, they're going to come up and show me something. So I'm going to run down here and go for the normal thing, which is give me a virtual machine, and you can see I can ask for lots of things. I want a web application, I want a network, but I'm going to say give me a virtual machine, and he's going to say, Damien, what would you like to call that virtual machine? And I'm going to say it's Tech Days 2016. And of course, he's got some questions. Where are you going to put the hard disk for that machine, Damien? I need to create a new place to put them. And he immediately switches me over to another resource for storage. So I'm going to call this one Tech Days 2016 as well. So we'll keep the storage names the same. And then he's going to come back and ask me what network am I connecting to. And I haven't defined that network. So as we looked at how that flow works, we're now going to give him a name. And we're basically going to call that the Tech Days 2016 network. Now, a network obviously is, you don't get storage or network with one question answer normally when you build infrastructure. So behind the scenes, when we look at the JSON file, we will actually be able to go in here and start looking at things like what IP ranges do I want on this network, and so on. So we can actually go in here and do additional configurations. But if I just take what I have right now and click Add, in the background, you'll have seen that the JSON file has actually been expanding. And you can now see here, essentially, if I click on the let's say the network one, the Visual Studio does its magic IntelliSense stuff and reroutes me to where we are on the particular file. And I can start seeing the dependencies, the display names, address pools, and he's already essentially been building parameters. So he's going to ask me for things that I need when I start doing deployment. But I can also go in here and say, look, I want more. Here's my virtual machine, but I want you to do more with my virtual machine. So I can now actually turn around and say, well, I'd like that virtual machine to be part of an availability set. And I'm going to call this one my Tech Days set. And I might also make a decision saying, you know what, I'd also like that virtual machine to actually have a desired state configuration. So again, right clicking on the screen, following normal wizard rules, it is going to give me context awareness. So he's offering me the PowerShell desired state configuration extension, and we talked about where those fall in the picture, and I'm going to call this one my DSC. Okay, so and it's going to be wired up.
Damien, we're going to need to wrap in just a moment. My big question for this is, can I take this exact same template and either do a deployment on Azure Stack or on Azure? Is it exactly the same template, or do I need to make any changes to it?
No, it is 100% the same. And this really happens when I come in here, and if I want to deploy, I simply pick a new deploy. I can log in and select, in this particular case, I've signed up to my Azure Active Directory. Azure Active Directory will have a subscription that might be hosted on Azure or on Azure Stack. In this particular case, it's on my Azure Stack environment. And then once I've essentially picked the resource group that I'm going to deploy to, I can go. It is Azure, and that's the key piece, Rick, is as we stated through this whole thing. Azure and Azure Stack is Azure. The only difference is the location that we're deploying to is your data center. And as long as that resource manager is bug-free in TP1 and everything is working great, then that template will work in either of those locations. And that's ultimately it. I can hit the deploy button once I've essentially answered the questions for my different servers. So I need a quick name for this thing. So we'll just go tech, and I go sysadmin, quick password, and an availability set name, so HA. And at that point, I just say save the password in plain text. Don't do that in production, of course, and go deploy. That's it. We're off to the races. Now I've got essentially a set of PowerShell scripts running in the background who are essentially calling home, looking to find my Azure. So the location happens to be Damien's basement, or it could have been Azure UK. It doesn't matter which of the Azures we target, and off we go to the races. Everything works from there. We've checked this code.
Damien, we're going to get cut off in a moment, so that's a good place to stop, because that's going to segue really nicely into what Taryn's going to talk about in about 5 minutes. We're going to have to disappear so we can get him wired up. I just want to say a big thanks to Damien, who's got up at 4 o'clock in the morning in Minnesota to do this. That was a really interesting session. It was a great introduction to containers and Azure Stack. And as we continue our story through the day, what we'll do is we'll take the template. We can take the template that Damien's just been working on and plug that into Taryn's Octopus deploy or release management deploy, and work our way through our DevOps deployment story. So Damien, big thanks for that. I'm sorry I've got to cut you off, but we've overrun. We need to start again at 1:15, so we've got about 5 minutes to plug Taryn in, who's standing here with his bow tie on. So big thanks.
Thank you very much, Rick, for having me. And it's been a pleasure, and I hope everybody's been enjoying the session so far, and have a great day.
That's great. Thanks, Damien.
I'll be online and monitoring the Q&As for a couple of hours as well, so hopefully I'll see some people communicate.
Okay, so back in 5 minutes with Taryn Aurora to talk about release management and Octopus deploy. Thanks very much.
To reality. And today I hope that we leave with at least some working knowledge of what the technologies are and how we can work with our IT partners and start lining up what it is that we need to essentially deliver on in order to enable us to bring out different technologies through infrastructure. So my background as an IT pro has been really on the actual fabric. I've been working for a number of years as an MVP, focusing in on the private cloud, Hyper-V, System Center, and the software-defined world of networking and storage. And of course, then the piece that has bridged me towards automation has been, to DevOps has been two main areas. That would be, of course, automation and authentication or identification. So the federations and the Azure Active Directories of the world, where I've had to build lots of relationships with my partners in development and also, as a reverse of that, be their representative as I worked with my own partners in the networking teams and stuff, so that we essentially knock down the balls and start working as one single unity. And it's from that perspective that essentially has helped me to start really understanding in super high cadence.
Okay, so what are you gonna run through today? Are you gonna do some demos of Azure Stack and containers? Are you gonna talk to us about what we need to do to implement that ourselves?
Yeah, that's exactly what we're going to try and do. Now, we prefix everything that some of this stuff is still very early preview. So some demos probably will run very smoothly, and some demos may give me a slight challenge. We'll see how that goes. But what I will do is I will go through essentially the two major players that are now coming up in the Windows Server 2016 solution stack as we get closer to general availability. And those are, of course, containers and Docker, as we've seen from the Linux world. And then the second one, which is, of course, the Azure Stack, essentially Azure, but in your data center. And we will spend a little bit of time just understanding what both of those technologies are, how they work and why we care about them, and ultimately how they become the foundation for us to ultimately give us infrastructure as code.
Okay, well, that sounds like a great thing to talk about. Well, we got 45 glorious minutes of that, Adrian, so take it away. Welcome back. Today is DevOps Day at Tech Days Online. by the miracles of modern technology, and because he's an absolute trooper, I'm sitting looking at my screen now, and the marvelous Damien Flynn is here with us on Skype. It's 4 o'clock in the morning in Minneapolis where he is, but still he's here, he's online, and he's going to talk to us about Azure Stack and containers. So Damien, how are you doing this morning?
I think the matchstick's starting strong enough to keep those eyelids working. Good morning. How you doing, Rick? It's a pleasure to join you.
I can be enthusiastic enough for both of us. So just to set the scene a little bit, I was talking a few moments ago, Damien, about the culture and the concepts of DevOps. And I was talking about how things like infrastructure as code is key for declaring our environments and being able to push those out consistently between development, test, and production. And I was talking about also consistency between on-premise and public cloud. And I'm going to enjoy sitting back and relaxing for 3/4 of an hour while you take us through all the cool stuff.
Perfect stuff. And at any point during the presentation, if there's some questions or if you feel like we need to jump into specific areas, please do feel free to nudge in there. I'll try and stop talking for a moment or two and just see if the feedback on the channels is coming in or if there's stuff that we should actually clarify a little bit further. So with that, good morning all, and thank you. I feel a little bit special, apart from the fact of sitting here at 4 o'clock in the morning in Minnesota, actually at another conference. I'm at the Microsoft Management Conference, or the Minnesota Management Conference as it's known here, MMS, focusing on this same type of technologies. We're talking here about the cloud and how things work, and it's quite interesting to be sitting on a DevOps call, which is mostly about development. But my background is essentially an IT pro, and I think that's a tribute to where this technology is coming from and how this enablement for giving DevOps type solutions is now becoming far closer.
And hosted cloud. And I think really the stuff that you're going to talk to us about now really starts to show how we can enable that with the power of Azure Stack, which is obviously Azure in a box that I can run, and containers which really span both all three of those environments. Is that right?
Yeah, I think that's very fair, to be honest. I think what we're looking at here is really addressing that first bridge that we have in that DevOps scenario of trying to figure out how can we start implementing and delivering on a solution that allows us to provide that same agility from IT to get that infrastructure in place that keeps up with the cadence that you're working on from a development side. But more importantly, take that same information and deliver it as actual code. It's no longer shipping boxes and patching cables, but it's actually implementing together with our friends in the development teams and in the network teams and in the network groups to actually come up with one single recipe, which is just a set of code, and deliver that out so that we can effectively deliver what it is, the infrastructure that is needed in today's DevOps world.